Thanks, everyone. Hope you guys are having a good morning so far. So I'm Fabio Fleitas. I'm the co-founder, technical co-founder at Tesorio. And I'm here to talk to you about tools to help manage large Python code bases. So quick background on me. I co-founded my company back in 2014. And we went through Y Combinator in 2015, and since then been growing and everything. So we've been doing a lot of work. Our code base is in Python Django. So hopefully sharing some of the stuff that we've been doing that's helped us kind of scale up our engineering efforts. So off the bat, I'm going to start off with open source tools that you guys can use. So and hopefully start off with that. So one of the most important kind of tools that's come out very recently is a tool called pip-tools. I'm sure most of you guys are already familiar with pip. It's still pretty standard out there to use pip, like to install any dependencies or any packages from the Python ecosystem. But recently there's now a tool called pip-tools that basically has become the de facto kind of standard for managing Python packages. One of the things that it does best is basically manage both pip and virtual environment in a single place. And so with that comes a lot of really good benefits. It also kind of manages top-level dependency management with a pip file, as well as kind of like a lock file that helps you manage manage sub-dependencies, as well as create deterministic builds. So funny enough, I actually spoke at PyBay last year to try to help with Python package management using another tool called pip-tools, which is actually no longer relevant. So that talk that I gave last year is completely irrelevant now, because it tried to solve some of the issues that pip had, which were around top-level dependency management, as well as building deterministic builds. Pip was not really built very well for that, and pip-env solves that really, really well. So some of the benefits for Pimp EV is, again, doing that kind of dependency management at top level as well as lower level. So you end up creating better security for that, as well as creating deterministic builds, which is super important. It also better manages dev requirements as well as production level requirements, which again was a huge issue between having pip and requirements.txt, as well as virtual environments. So kind of consolidated a lot of issues using best practices from other languages, such as like NPM, Yarn, and stuff from the JavaScript community that have done a pretty good job at that, and kind of putting it in the Python ecosystem. So what it looks like, basically, you have a top-level pip file. It looks pretty similar-ish to your like requirements.txt file, but you only set up your top-level dependencies. So if you want to install like Django, if you want to install requests.py or anything like that, you just define those. You can define, similar to requirements.txt, which versions that you'd like to include. But they do actually even recommend kind of keeping a star or something so that you can keep up-to-date versions. And so it helps with any security issues and stuff. And so as you can see, basically it'll automatically manage a lock file. And so basically the lock file will determine any sub-dependencies that it needs, as well as keep a hash of it all. So it's really secure. So if anything happens, like let's say PyPy or wherever you're installing your Python packages from gets taken over and your packages all of a sudden change, it's able to detect that. And so it allows a lot for a much more better security than pip by itself had, as well as other tools like pip-tools that we were using for a bit tried to solve. So at the end of the day, pip-ev seems to be really the future of Python package management. So if you're not using it now, it's really kind of like the best practices at this point. It's not really that hard to switch over. We've already kind of done it for some of our Python code bases, and it actually wasn't too big of a struggle. So definitely recommend switching over to pip-ev if you haven't. The next open source tool that I'm going to talk about is actually called Flake 8. So Flake 8 is essentially a linter / style guide enforcement tool. in case you guys are not familiar with what linting is, the previous talk actually talked a little bit about it with like flakes and other things. But essentially what it does is, and I actually had to look up the exact definition, was just curious. And apparently, it originally was a particular program that was flagged, that was built for C. And it was built to basically flag suspicious-looking code or non-portable constructs for C developers. What ended up happening is it was so useful for that language, and basically and it started becoming so popular for other languages that it kind of became like a generic name for tools that help you kind of flag either suspicious software or even style guides. So Flake and linting are super important for managing your Python code bases for a couple of reasons. So first of all, it will help detect any sort of common bugs. So syntax issues, like if you imported something that was not used, potentially like typos with your code base, it actually is able to catch a good amount of bugs that could be hard to catch just by looking at your code base. And someone just kind of reviewing it by eye. So it kind of automates that. On top of that, one thing that I've found really important from a code base management, especially as you're kind of like scaling engineering teams or anything, is like actually having a consistent style is, I think, really important. It makes it really easy, especially when you're bringing on new engineers or you're going to go into another Python project that you haven't worked on before, having a similar style, how's the readability of the code, it kind of, you already feel very familiar and comfortable, as opposed to, for example, JavaScript kind of throws you in the wind and kind of you can do almost whatever you want. I really like the Python community for that aspect, kind of sets standards and kind of enforces that. So Flake 8 kind of brings together a bunch of, it's essentially, as it says, kind of like a wrapper around a couple of different tools that helps kind of keep and maintain your code base style consistently, as well as catch a couple of really common bugs. How to kind of use it. At the end of the day, you'll create a dot file called .flake8. As you'll see in my presentation, almost all the tools require kind of a dot file to kind of configure it. But it's pretty straightforward. You kind of tell it what types of things you want to include, exclude. So you don't, like for example, we have a Django code base, so we don't want to necessarily test against our migrations file because that's auto-generated from Django and stuff, and a couple other configs. At the end of the day, and I hope this doesn't look too grainy, you just run Flake 8 on your command line once it's set up, and then it'll be able to kind of tell you literally which file, which line of code, where the issue was. And so as you can see here, I accidentally had a little error with instead of double star for quargs, and it's able to catch that. So it's able to catch those types of things as well as style issues, which is pretty awesome. Again, it won't catch everything, but it's a really good starting point to automate some of your testing in your code base. The another big tool that we're using, it was slightly covered in the previous talk, is Coverage.py. It's basically a code coverage measurement for Python. And in case you're unfamiliar with what code coverage is, or you didn't attend the last talk, basically code coverage is basically, it tries to measure what parts of your code were used when it ran a particular function. So typically you use code coverage when you're running tests, and it basically measures every part of your code base that was used. And essentially, at the end of the day, what it does is try to see how much was covered by your test cases. So when you run your test case and you run coverage on top of it, it'll tell you what was run, what wasn't, and ultimately kind of give you a sense of how much of your code base is tested. As the previous talk mentioned, it's not foolproof. It's not really meant to tell you whether or not your code is bug-free or even tested. But at least having 100% code coverage does give you a little bit of benefit. For one, it kind of helps you if you're ever going to refactor or make sure that your code is at least tested and that everything was run through and that you didn't have any accidental basic bugs. So having a good coverage, again, it's always a balance of like how much you want to cover versus how much effort it is. So 100% code coverage is not ideal, but you really want to try to cover the most important parts of your code. And this kind of helps you at least get a sense of what needs to be covered and what already is covered. Some organizations have code coverage requirements. So like, for example, some companies will require that you have a certain coverage before you actually can merge your PR in, or sometimes you can even set up so that if your new code reduces code coverage by a certain amount, it'll immediately reject it. And so kind of depending on how you want to structure your own code or your company's code, this could be pretty helpful, at least to make sure that you're maintaining kind of a good code quality base in your code base. So yeah, I guess to how to use it. Again, you'll set up something like a coverage.rc file. Here, there's pretty standard ones that you can kind of start off with. Almost all these tools kind of have a basic config and setup that you can use, and for the most part, they're pretty good. Definitely just want to include or exclude different directories or anything that you'd want. And then at the end of the day, you basically just do two things. You do coverage run, and then what you typically run to run your test case. So in our case, since we're Django, we'll do manage py test. So we'll do coverage run manage py test, or run our entire test suite, and then at the end, you can actually create run coverage HTML, which gives you a really nice, actually, like HTML page that will give you kind of an overview of all the files in your directory, what was run, what was the coverage, what was partially covered, and everything. And you can actually drill down into each one of these. So you can actually see for each one of these what was missing, what wasn't, and it kind of makes it really visual and really easy for your team to kind of manage how much of your code base has been covered and what could be covered better. So python-dotenv, I wanted to include this just in case you weren't using pip-env or had other constraints in your code base. Pip-env automatically actually detects if you have a .env file and will load it. Essentially what a .env file is a local, basically local environment variable. So if you have a bunch of different Python, different repos, different code bases, the environment variables might be different between code bases. And so it's not very practical to have like global level environment variables, which is how Unix systems are kind of really built for the most part. So what local .env files help do is kind of create almost like an isolated set of environment variables for your code base. And so at the end of the day, what it looks like is you just create a local .env file in that repo. And typically you want to git ignore this. What most companies do is they'll do like .env.sample or something, kind of give like a sample structure what environment variables that code base already uses. Like if you're using anything for Django, it's part of your settings or anything like that. And so you'll set there in your local .env that you git ignore, you'll set up whatever environment variables you want, like AWS secret keys, for Django secret keys, anything like that is important, but you don't want to keep, you want to have different repos. And then at the end of the day, it's pretty straightforward. You just from .env import load .env, and as long as it's close to where your settings are or in the same directory as you're running it, it's able to pretty much detect it. There are other ways in case you have the .env somewhere else. It can also set up and load. But it's cool because then you don't have to keep like a global environment variables for each repo. You can just kind of have one isolated one. It's pretty helpful. Again, pipenv already does this, but if you're not using pipenv or have other constraints, python.env is very useful and very practical. So Bandit. This is a really so now the next two ones that I'm talking about are actually around security. And so when you're starting to grow your code base and you've had a lot of legacy code and a lot new engineers and everything, security becomes a big concern. And so what Bandit is trying to do is actually look at your source code. Look at your Python code base and evaluate if there's any potential security issues, common security issues in that code base. And it looks for things like, for example, if you are using eval, like eval can be dangerous, right? And it'll like tell you like, hey, someone used eval. Or if you're using Django or something and you put a raw SQL somewhere in there, it'll like tell you like, hey, be aware. It doesn't necessarily mean that there is a security vulnerability, but it warns you about the potential about it. And so this is super important when you start having a big team. Like you might have junior developers that aren't familiar, and so they just kind of throw in evals or just start using raw SQL here and there and not like sanitize the parameters or anything. And so this kind of gives you a little bit of a sane kind of perspective on like what's going on with your code base. And then it does give you the flexibility of ignoring certain ones. So if you feel confident that there's a certain security concern that it flags, you're actually able to automatically ignore it. But at least this way, it's like purposeful. So the default is like insecure. If you want to count it secure, you have to code and explicitly say that. So at the end of the day, it's an automated way to kind of help you check for very common security concerns. And at the end of the day, you'll have kind of peace of mind that your code base at least has a certain level of security. Again, not foolproof, but the good thing is that it's automated. So it's not like you have to make sure everyone's like really checking the PRs. You can put this as part of your CI, and it'll kind of help you do that. So again, as with everything else, you'll create a .bandit file. Here you'll select what you want to include, which directories you want to include for it to check, as well as potentially if you want to exclude certain checks on it. It has you can go to the open source repo and you can see all the things that it checks for. There's particular ones you don't really care about, like for example, try, accept, pass. For whatever reason, you can go ahead and just like globally ignore those, or you can ignore it line by line. At the end of the day, this is kind of how it looks like. You can run it against your code base, and it'll tell you, which is pretty cool. It'll tell you by severity and by confidence. So it'll try to categorize like how severe like these errors are, low, medium, high, and uncategorized or undefined as well as how confident it is about that. So you're able to kind of prioritize. If you already have a really big legacy code base or anything like that, you can tell it to only prioritize high severity ones or high confidence ones. And so it kind of helps you, especially if you already have a very big code base, so you don't like get overwhelmed by number of potential security issues. But it's pretty cool. And it does it all statically, if I remember correctly. So it's not like it doesn't have to run your code. It just looks at it and builds a graph and kind of like looks to see if there's any potential issues there. And it's pretty cool. The next one is called safety. This one actually checks for security issues in your dependency. So based on your requirements or pip file, it'll actually look through that. And so this company it's actually a company. They have like a database of known Python issues, and they're pretty much on top of it. And they've open sourced it. The open source is basically, if I remember correctly, updated once a month. If you're a company and you want to be like a little bit more up to date, you can actually pay for like a subscription, and it's like more kind of real time security updates. And so again, the difference between this and Bandit is that Bandit is looking at your code base, the code itself that you're running. So like it'll look and see if some developer wrote eval or something in your code base. Safety is looking at your dependencies. So if like you pip installed something and it's like insecure for whatever reason, it'll let you know. As well as if there were vulnerabilities known for like very common packages, it'll tell you like 1.01 is insecure, but 1.1 is secure. So it'll tell you to like update it, which is, again, once you have a really large code base and you have so many dependencies, it's like it's impossible to stay on top of this. So having something like safety to be able to just quickly check like what's insecure, what's not, and help you and your team kind of manage priorities of what packages need to be updated and the impacts on your code base, again, automates that for you. It's pretty cool.
Can I ask a dumb question?
Yeah.
You talk about security here, and you talk about a package.
Let the world know your question.
My dumb question is, you're talking about secure packages, maybe an insecure version.
Yeah.
How does it define that exactly?
Yeah, so typically how most of these, so safety and most of these like dependency checkers aren't like scouring and going through and trying to check for securities. What typically happens is the package maintainers themselves put out like a notice or something that says that there's an issue, or like someone brought an issue into the repo that says there's a security vulnerability with this XML package, and so you need to update this XML package to be secure. And so then it becomes like a kind of publicly known thing that like they are looking to it, and that then the maintainers will say this package has a known vulnerability, everyone should update to 1.1. And so basically what these guys do is they just stay on top of that. Like they're just on top of all the top like Python packages. So again, it won't catch like if you just go and pip install Smojo's like little package to like parse URLs or whatever. But as long as you're using well-known kind of in the Python community, and like the maintainers kind of do a good job of alerting that, that's their job. Basically, safety's job is to just be on top of that and to alert potential customers about any issues in their dependencies. Good question. And so the last one of the open source tools, if I remember my presentation correctly, is Precommit. Basically what that does is helps you run all of that we just talked about in an automated fashion before you either commit or you push to your GitHub repo. So a little bit quick background in case people are not familiar with what Git hooks are. So basically you can, for your repo, set up hooks that are basically bash scripts that run either before or after certain commands are run. So you can set up a Git hook to run right before you pull, or right after you pull, or right after you commit, or before you commit, push, pull, anything like that. And so at the end of the day, they're really bash scripts. Like Git didn't want to do anything crazy complicated. But the issue with having, there's a lot of good reasons to have obviously Git hooks. So like before you push, maybe run some Flake, run some Bandit to just make sure that like you didn't accidentally add stuff in there. But the issue with bash scripts, if you're familiar, is that sometimes they're not very good across systems, especially if you're using Windows or you have developers that are using Windows. And so what Precommit tries to do is kind of consolidate all of those issues into and kind of have a cross-platform solution. So at the end of the day, it's automating like Git hooks so that it works across all your developers. So you can have one actual functioning Git hook that can check for everything. And so at the end of the day, pre-commits should be, the hooks that you put into your pre-commit should be really fast. Things like Flake, things like Bandit. You shouldn't be like running your entire test suite as a pre-commit, but things that are quick so that you can like make sure you don't accidentally push with like a lint error or anything like that is pretty cool. And so, and then I just remembered. So basically, it's pretty straightforward. You pip install pre-commit, and then you just pre-commit install. Now, the one thing I personally think is by default, it's by its name. It does it right before every commit. I think that's really annoying to have to run linting every commit because I like to commit a decent amount. So I actually make it run every time I push. So if you want to do that, it's just hook type pre-push instead. So actually one of our engineers was like annoyed yesterday because we added something and then there's like, it's taking too long. And it's like, oh, just do it on push. And he's like, oh, okay. So just a little personal anecdote there. Again, pre-commit config file. This one's actually pretty useful. Basically, you should signify what things you want to run in which order. It also has a pretty cool thing which allows you to set it up via a repo. So you can have like an organization level set of commits that across all your Python code bases could be used. And so you can just say like, based on this one, run these hooks that we name in this repo. And so obviously Precommit has their own set of hooks, but then you can also have our local, like for example, in our local, like Flake 8 and ES are two of the ones that we have. So every time we push, we check those real quick because it saves time in case your CI is running and then you fail at linting. It's like kind of silly to waste that time when it's pretty quick to check. And then, yeah, so basically, as I'm pushing, it just goes through, it like passes. It can even detect if it shouldn't even run. And it'll skip it. And then if there's any errors, for example, Flake 8 here failed, it actually won't even push. So like it'll fail it before you push, so it saves time there. Cool, so that's the end of the open source repos. Do want to talk about a couple services that I think are pretty crucial to kind of help him maintain all of this. And first is definitely CI. So in case you guys are not familiar with what CI is, it basically allows you to run essentially a set of instructions that help you kind of make sure that your code base is well maintained. So for example, in our CI, we run all these checks. We run Flake, we run Bandit, we do run safety, although we don't fail against it. Because sometimes you don't have control. That's the one thing with safety. You don't have control over, you can be aware that there's a security issue, but there might not be a solution. So you shouldn't really fail if there's an insecure package because there might not be a secure one. But basically allows you to run through your entire test suite and and do that. Circle CI and Travis CI seem to be really kind of like the leaders. Circle CI is really targeted towards more companies and enterprises. Travis CI seems a little bit, although they both work for open source as well and everything, but just seems like Travis CI has been more focused on the open source community. Circle CI has been more for like enterprise and stuff, especially for deployments and everything. And then one thing that I would definitely enforce is actually you can enforce GitHub to only allow merges of PRs as soon as CI passes. So it has to run Flake, it has to run all your test cases, has to run everything. Otherwise, that PR is not allowed to be merged in. And even for your own personal projects, I would definitely ensure that, because it just makes sure that your code base is well maintained and no one's just pushing stuff in that could potentially break it. This is kind of how it looks. This is Circle CI at least. And so like, for example, the bandit check failed, and so it'll be red. It won't let me merge that PR in, and it'll allow you to kind of drill in into what's going on and stuff. So that's pretty cool. And then last open service that I would definitely recommend is error tracking software. If you basically, and we use Sentry. There's a bunch of other ones like Rollbar, and I think Rollbar is the name, and there's like a couple of different ones. But essentially what it does is in a production environment, lets you make sure that you're checking for any errors or anything, and then does pretty awesome reporting. So it allows you to kind of see like almost like exactly where in your code base did it fail, what was the state of the code base there, what were some of the variables that were around at the time. It tells you like how many times this occurred in the last and days and hours, which of your users were affected, and kind of really drill down. Honestly, like, I don't know how we like if we didn't have Sentry, it'd be a nightmare. It just kind of allows you really easily debug and find issues in a production environment, right? Again, even if you have 100% code coverage or anything, you might still have bugs. So this at least helps you catch things as they happen in a production environment. It's pretty cool. Yeah, in summary, these are all the tools that I mentioned in the talk. And yeah, happy to answer any questions.
Does anyone have any questions?
What's the difference between Sentry and Logstash and Splunk?
I don't know the second one, but Splunk, if I remember correctly, is more logging. So there's a difference between logging and error tracking. Logging is just like you say like logging.info started worker or started this task or whatever. So it just gives you kind of a little bit of info. Sentry in particular is really focused more on like error handling. So if your code base has an error or there's something, so like what one common way to do is actually set up your logger so that anything warning or above gets sent to Sentry. So if there's any errors or exceptions or maybe even warnings, we have it sent to Sentry. But it also detects things that you did not expect. So if an exception was raised and you didn't catch it or anything, it'll also get sent to, you can also have it sent to Sentry automatically. So logging just kind of gives you info, but doesn't give you detailed aspects of like what's going on. And logging has to be proactive. It's not, for the most part, reactive. While Sentry can be reactive to errors that happen in your code base.
So a question about dependency management and Pippin.
Yeah.
So there's always sort of a tug of war between the goal of keeping everything up to date versus being surprised when something updates itself and breaks something unexpectedly.
Yes.
So we developed this habit of pinning dependencies.
Yes.
And then Pippin comes along, and their official recommendation is to star everything, so you get the latest.
Yep.
And then sort of let the pip-file.lock automatically manage that. But that just seems weird because you sort of haven't specified a version, and yet you're specifying a version in the pip-file.lock, but that only gets updated automatically if some developer updates something and it auto-generates that change. How do you deal with that or recommend dealing with that?
Yep. Yeah, that's a huge issue. So it kind of depends on like kind of what your goals are as an organization. So for example, one really good example for us is we pin versions for Django, right? Like from our perspective, we want to be on the latest LTS, but we don't want to automatically jump to 2.0. You know, we want to be on 1.11, but if there's a new security issue or whatever, we want it to be updated and be updatable, but we don't want to automatically jump to 2.0. So that being said, It kind of depends on how your organization kind of wants to handle that. You definitely need, and that's one of the things that requirements kind of, depending on how you approached it, didn't do very well is like, at the end of the day, what you really, really want to strive for is reproducible, deterministic builds, right? That at the end of the day is a goal, that if you if you run it locally and you run it in production, it's the same exact environment. How you handle upgrades and stuff, at the end of the day, I think it's more of an organizational process than like a code-based process, in my opinion. What I would recommend is, again, I think the pip file works pretty well. I would not just nilly-willy kind of upgrade packages, because it can, depending on how well the maintainer is, it might break stuff. And so you should always be careful about upgrading. And so you kind of have to kind of manage that and see kind of how you want to approach that from an organizational perspective more than anything else, I think.
Thanks for a great talk. I have a quick question about the performance. Do you have any specific recommendation for performance, the Python code?
Sorry, I couldn't hear.
So do you have any specific recommendation for Python performance testing or something?
For testing?
Yeah, for testing or...
Yeah. I mean, the two, it seems like the two main, again, it depends if you're using like Django or whatever, but it seems like the two main Python testing frameworks are PyTest and Nose for the most part. We personally use Nose, but and they're kind of different. But so I guess, well, they're slightly different. Nose is kind of like a test runner, and PyTest allows you to kind of create your tests. But it seems like, at least from a runner perspective, Nose is very large in the Python community. It helps you kind of run your tests, and I think it even allows you to like parallelize and everything. And then from a like testing framework perspective, obviously you can use the unit test stuff from Python, but PyTest seems to be pretty popular too. But it kind of depends on the framework. So Django has its own built-in like test based off of unit test, and we tend to use that because it's not that big of a deal. But we use Nose for running all our tests, for example.
Hey, thanks for the talk. PEP8 and therefore Flake8 say the imports need to be in a certain order. And yeah. It's cool that it lints it, but it's not going to fix it for me. And this is where I throw my hand and be like, life's too short.
Yeah.
And so I've also like looked into code formatters like YAP for black, but as far as I know, they don't do much besides just white space. So do you have any solutions here?
Yeah, so I was almost going to include, and I think it's in the, if you look on the website, I was almost going to include a tool called isort, which essentially automatically sorts your imports based on the recommended, and you can also configure it same, like if you had like for example, if you have Django REST framework, you want it in its own little place and stuff, you can have it kind of do that. The issue is, and we found this when we were working on our stuff, was that in practice, for whatever reason, isort is not deterministic. So you can run it and it'll fix it, and then run it again, and it'll fix it again. And it's just like constantly fixing itself. And so it's, to me, that was like insane. That like there's no, that the way that we were running the same command, and it just kept like swapping like the order of two things. And so it would be kind of impractical, because then if you add isort to your pre-commit or you add isort to CI, it could randomly fail. And I've never liked those auto formatters for the most part, because I think they do some weird funky stuff sometimes. And then also when you're writing code, it'll just, like if you put it in a pre-commit, it'll just like randomly change a lot of stuff, and then you'll just have this huge git diff randomly. I've always found those auto formatters, because they're not deterministic, like if you run it n times, it might change every time. Really weird. So I like, for example, for imports, we do it manually. We literally just do it manually, and we just check it. It's not that big of a deal to check manually for the most part. So that's unfortunately how we've done it, because I haven't found a good solution.
All right. Well, time is up. Let's give another warm round of applause